People often ask me about Model 3 production hell. It's a phrase I used, production hell, and it was real. But the thing people seem to focus on, the thing they write headlines about, is me sleeping on the factory floor. They're obsessed with that image. They talk about the sleeping bag I kept in a conference room. They talk about the small, narrow, uncomfortable couch I showed Gayle King in the CBS interview. They see it as some kind of sacrificial act, a PR stunt. Some people even think it's a flex. They are completely missing the point. They're focusing on the wrong thing. The point wasn't comfort. The point wasn't sacrifice or fatigue. I didn't have time to worry about being tired. In one interview, I said I didn't even have time to go home and shower. That wasn't a joke. The point is physics. The point is time. The point is latency. When your company is on the verge of death, when you are staring into the abyss, every minute is an eternity. Every minute is cash burning. Sleeping on the floor wasn't a choice. It was a logical necessity. Look at the numbers. In 2018, during the worst of it, Tesla was burning cash at a rate of over $7,430 per minute. Our free cash flow had been negative for 5 straight quarters. We reported a record net loss, around $710 million in Q1 2018 alone. The analysts were right. We were about a month from bankruptcy, 1 month. When you are 1 month from death, do you waste time? This wasn't my first time in this situation. I was there with the Model X, the car we had insanely over-designed. I had to sleep on the Fremont factory floor then, too. But the Model 3 was worse. It was a crisis on a totally different scale. And here's the critical thing. It wasn't one fire. It was 2 fires simultaneously. Fire number 1 was in Fremont, California, where we assembled the car. That's where the crazy, complex network of conveyor belts and the stupid robots were. Fire number 2. And the bigger fire was hundreds of miles away at Gigafactory 1-inch Sparks, Nevada. That's where our main production constraint was. I wasn't just sleeping in Fremont. I was camping on the roof of the Gigafactory. We sat around a campfire on the factory roof, drinking whiskey, singing Ring of Fire. It sounds fun, but the reason I was there was because, as I tweeted, it was less time than driving to a hotel room in Reno. That drive took 30 minutes. 30 minutes there, 30 minutes back. That's an hour. In that hour, at a burn rate of $7,430 a minute, we just burned nearly $500,000. That 1 hour was an hour an engineer could have spent debugging a piece of the line. My presence in both places, the sleeping bag in Fremont, the tent on the Giga roof, was a physical bridge. It was an attempt to connect 2 failing systems. Personal responsibility, to me, means minimizing your personal latency in the problem-solving loop. You cannot phone in a crisis. You have to be there. You have to breathe the air. You have to see it. The physics of leadership and absolute responsibility, I don't really think about leadership as an abstract concept. It's a fuzzy word business schools like to use. I think about it in terms of physics. Leadership is a force vector, simple. A company is a complex system trying to move in one direction. There will always be friction. There will always be bottlenecks. The job of a leader, especially an engineering CEO, and I have always considered myself the chief engineer of the company, is to identify exactly where the greatest friction is and apply their own force at that point. In 2018, the friction was not in a boardroom. It wasn't in the Excel spreadsheets, though they looked terrible. The friction was literally on the general assembly line and in the battery module assembly zone. So I was there. I was living in the factory. When journalists asked me about reports of unsafe working conditions or toxic fumes, I said I was literally living in the factory. If these toxic fumes, I'm breathing them. Fortunately, there weren't any. But the point is, you must share the pain. This leads to a fundamental philosophy I try to apply at all my companies, from Tesla to SpaceX. Walter Isaacson wrote about this in his biography. It's my rule of responsibility. Every part, every process, and every specification needs to have a name attached to it. This is the core of it all. In a traditional company, everything is anonymous. Everything is a department. If a part fails, it's engineering's fault. If a process breaks, it's production's fault. If a legal requirement causes a delay, it's legal's fault. This is how people hide. We don't do that. We can't, at Tesla, if a part fails, I don't want to talk to a VP who manages that department. I want to talk to the engineer who designed it. What's their name? I want them to explain to me why it failed. I'm not going to yell at them unless they were lazy or dishonest, but I want them to own it. They must feel the gravity of that failure. It's the only way to learn quickly. Now, extend that logic. If a part has a name attached to it, who is responsible for the entire line? Who is responsible for the product? Who is responsible for the company? I am. My name is attached to the entire system. Me sleeping on the factory floor was the physical manifestation of that rule. It was me saying to the entire team, my name is attached to this. I'm responsible for this failure. How can I ask a young engineer to take absolute responsibility for a single bolt if I, as CEO, am not taking absolute responsibility for the entire factory? I can't. It would be hypocrisy. My presence on the factory floor was about alignment. If the engineers and workers are putting in 100-hour weeks, 120-hour weeks, and they were then, I must be there too. If they're there at 3 a.m. trying to debug a robot, I am there at 3 a.m. helping them debug that robot. You serve your team. Your team is not there to serve you. You are there to serve them and help them do the best possible job for the company. My job as leader is to remove barriers. And in 2018, the barriers were technical, complex, and happening in real time. The only way to remove them was to be there. Breaking the chain of command. The anti-MBA philosophy, there is another more tactical reason for me to be there. It has to do with how information moves. Most companies are run on what you might call the MBA model. They have departments, they have silos, and they have the chain of command. I've sent an email to Tesla employees about this. I believe that communicating through the chain of command is exceedingly dumb. Here's how it works in a bad company. A worker on the line spots a problem. They tell their supervisor. That supervisor tells their manager. That manager talks to a senior manager. That senior manager talks to a director. That director talks to a VP. That VP then talks to another VP in engineering. That VP talks to a director. And so on. Until 2 weeks later, the information, now completely distorted, gets to the actual engineer who can fix the problem. This is insane. It serves only one purpose, to enhance the power of the manager in the middle. It does not serve the company. Information must travel via the shortest path necessary to solve the problem, period. I don't care about hierarchy. If a line worker needs to talk to me directly, they should. If an engineer in powertrain needs to talk to a designer in body, they should walk over to their desk and talk. In a crisis, the chain of command is death. It is the enemy of speed. It creates latency. It distorts the bit rate of information. Me sleeping on the floor was the physical destruction of the chain of command. It was a complete bypass. Instead of a 2-week information loop, our feedback loop became real time. A worker would see a robot misplace a part. They didn't have to fill out a form. They would turn around and say, Elon, this is broken. I would walk over. I would look at it. I would ask, why is it broken? The engineer in charge of that robot would be right there. They would say, the vision sensor is getting glare from the overhead light. I would say, okay, let's turn off that light, or why don't we build a small shroud around the sensor, or can the software compensate for it? Boom. Feedback loop from days to seconds. People call this micromanagement. That's a pejorative term. I've called myself a nano manager. I don't care about every detail. I care obsessively about the details on the critical path. When the company is on the brink of bankruptcy, everything is on the critical path. I sent another email to managers. I said, when I send you an email with explicit directions, there are 3 ways to proceed. Three options. Explain why I'm wrong. I always want to hear this. Maybe I missed something. Ask for clarification. If you don't understand, execute the directions. If none of the above are done, the email read, that manager will be asked to resign immediately. Staring into the abyss and eating glass. There's a saying that I've said, and I truly believe this. A friend of mine said it first, and I repeated it. Starting a company is like staring into the abyss and eating glass. People laugh when they hear that, but it is not a metaphor. It is the most accurate description of entrepreneurship I know. Let's break it down. Staring into the abyss. This means you are constantly facing the extermination of the company. Most startups fail 90%, maybe 99%. So you are always, every day, looking at the probability of total failure. You are saying, if I don't get this right, the company will die. This is quite stressful. That's an understatement. In 2018, we weren't just staring into the abyss. We were hanging over it by a thread. As I said, we were burning $7,430 a minute. We were a month from cash out. Wall Street analysts were writing our obituaries. The short sellers were throwing parties. The pressure was unbelievable. That is the abyss. I had been through this before in 2008, when both Tesla and SpaceX were about to die. I knew what it felt like to be waking up screaming in pain from the stress. 2018 was just like that, only at a larger scale. The second part is eating glass. What does eating glass mean? It means you have to work on the most painful, thorny problems in the company. You have to do the problems the company needs you to solve, not the problems you want to solve. As CEO, you are the filter for the worst problems. Every horrible, pernicious problem that no one else in the company can solve, it finds its way to your desk. You don't get to work on the fun stuff, like new product design. You have to work on the broken stuff. You have to eat the glass. And that goes on for a long time. Model 3 production hell was the perfect realization of that metaphor. The staring into the abyss was the financial clock. Every minute the line was down, I could calculate exactly how much cash we had lost. The eating glass was the actual work. It was walking the line. It was diagnosing a stupid robot trying to pick up a piece of fluff. It was realizing your supplier dropped the ball on the battery module line, and you had to rewrite literally 20 to 30 man-years of software in 4 weeks. That is glass. It is painful, unglamorous work that no one else can fix. Anatomy of hell. Now, let's talk about what I actually saw. When you are there on the floor, you see the truth. You don't see PowerPoint slides. You see brutal reality. And the reality was, we had been arrogant. I had been arrogant. The betrayal of the machine, the alien dreadnought nightmare. I had a vision for the factory. I called it the alien dreadnought, a factory of the future, highly automated. The vision was raw materials come in one end and cars come out the other with very little human intervention. I used to joke, but I was semi-serious, that the line speed would eventually be so fast you'd need a strobe light to see the car moving. The velocity of production would approach the speed of air. It was a beautiful vision. And it was wrong, completely wrong. We tried to automate everything. We built a machine that was too complex, a system that was too brittle. In an interview with CBS, I talked about it. We had this crazy complex network of conveyor belts. It was like a maze. It was everywhere, and it was not working. Here's the problem with an over-automated, brittle system. It has no resilience. If one single piece of it, one sensor, one conveyor motor fails, the entire line stops. And that's exactly what was happening. Constantly, we had to pause the entire Model 3 line multiple times. We did it in February. We did it again in April of 2018. We told the press it was planned downtime to improve automation. The truth was, we were trying and failing to debug the Rube Goldberg mess we had created. In the end, what did we do? We got rid of that whole thing. We ripped it out. We junked the complex conveyor network. The failure of the alien dreadnought was a failure in applying first principles thinking. I started with a bad premise. The bad premise was humans are slow, robots are fast, therefore an all-robot factory will be fast. The reality, the true first principle is more complex. Robots are good at repetitive, precise, high-speed tasks. Humans are good at adaptive intelligence. They can handle variability. They can deal with unforeseen situations. Mass production, especially of a new product like the Model 3, is full of unforeseen situations. Parts don't line up perfectly. A bolt gets dropped. A cable gets twisted. Robots are terrible at this. Humans are brilliant at it. By removing humans from the line, I had removed the line's ability to adapt. I had removed the factory's immune system. I created a brittle system, and it broke. It was my fault. The tale of the Fluffabot, the peak of engineering arrogance. If you want a single example that summarizes the entire insanity, it's the story of the Fluffabot. Yes, that was its real name, Fluffabot. Here was the problem. We had a part that was a fiberglass mat. It was basically fluff, as I called it. It was supposed to go on top of the battery pack for sound insulation to reduce cabin noise, and we, in our infinite wisdom, decided we had to automate the placement of this piece of fluff. Imagine this. We built a super complicated machine. It had a computer vision system, it had a robotic arm, all to try and pick up a piece of shapeless, flimsy fluff. It turns out machines are not good at picking up fluff. They are terrible at it. Human hands are way better at doing that. The human hand is an engineering marvel. It can adapt, feel, adjust. A robot cannot, so the line was constantly failing. Fluffabot would frequently fail to pick up the fluff or put it in a random location. It was a disaster. We had wasted incredible engineering talent, time, and money building an incredibly difficult machine to do a job a human could do in seconds. It was one of the silliest things we did. But the story doesn't stop there. It gets worse and more profound. As I stood there on the factory floor, watching this stupid robot fail over and over, I asked the team a very basic question, a question we should have asked at the very beginning. I asked, do we need this fluff? They ran a test. They drove a Model 3 with the fluff. They drove a Model 3 without the fluff. They measured the noise, the result. No change in the noise in the cabin. The entire part was useless, completely unnecessary. We had gone through all that engineering hell, all that delay, all that cost to automate the placement of a completely unnecessary part. We eliminated the part immediately. We junked the Fluffabot. This was a horrifying aha moment. The problem wasn't just over-automation. The problem was automating something that shouldn't exist in the first place. That moment, standing on the factory floor looking at the Fluffabot, was the seed for the manufacturing algorithm I'll talk about later. It taught me a lesson I will never forget. The most common mistake is optimizing something that should not exist. The confession, humans are underrated, after seeing the Fluffabot. And a dozen other less dramatic but equally stupid examples. I got it. My premise was wrong. So I admitted it publicly. I went on CBS, talked to Gail King, right in the factory. I went on Twitter to my 21 million followers, and I said it plainly. Excessive automation at Tesla was a mistake. To be precise, my mistake. Humans are underrated. People treated this as some shocking apology. To me, it wasn't an apology. It was a technical diagnosis. It was an admission that my premise was wrong, and we were correcting it. In interviews, I explained people are way better at dealing with unexpected circumstances than robots. The human hand, with its incredible adaptability, was a tool we had disrespected. The solution? Obvious. We had to bring humans back onto the line. We hired hundreds of workers. We redesigned workstations so people could do what they do best. Fine assembly, handling, flexible parts, problem solving, and let robots do what they do best. Heavy lifting, precision welding. But don't get me wrong. The humans are underrated. Confession was not a rejection of automation. It was the beginning of a smarter automation strategy. It was the understanding that the goal isn't 100% automation. The goal is the correct balance of humans and machines. Sandy Munro, a famous manufacturing consultant who tears down cars for analysis, had originally been scathing about our first Model 3. He was right. It was built poorly. But later, after we got through production hell, he analyzed it again, and he said that because of the painful lessons we learned, Tesla is now 10 years ahead of the rest of the industry. Especially when it comes to the manufacturing. Production hell was the price of admission for that 10-year lead. We paid our tuition. We learned what to automate, like mega castings, where we replaced hundreds of parts with a single one, and we learned what not to automate, like picking up fluff. The bottleneck of all bottlenecks, most of the cameras, most of the stories focused on Fremont. That's where the cars came together. That's where the tent was. But that is not where the real battle was fought. The real battle, the bottleneck of all bottlenecks, was 200 miles away in the Nevada desert. The real problem, battery modules, as I mentioned, I was camping on the roof of Gigafactory 1. Why? Because our primary production constraint was not final assembly. It was the battery module assembly line. Here's how it works. At Giga, our partner Panasonic makes the 2,170 battery cells. Tesla then takes thousands of those cells and assembles them into modules. We then take those modules and assemble them into battery packs. Those packs are then shipped to Fremont to be put in the car. The entire Fremont factory was starving. We had car bodies, we had seats, we had motors, but we couldn't build cars because we could not build enough battery modules. That's why I was there. That's why J.B. Straubel, our CTO at the time, is basically spending his entire life at the Gigafactory right now. The entire multi-billion-dollar company with over 450,000 pre-orders was being held hostage by one part of one line in Nevada. This is the theory of constraints in practice. Optimizing anything else, trying to make the Fremont line faster, was completely pointless. It was like trying to widen a highway when the bridge at the end is only one lane. A distant CEO in a nice office would get conflicting reports. They would hear from the Fremont team that they need more packs. They would hear from the Giga team that they are working as hard as they can. There would be meetings. There would be PowerPoints. There would be blame, garbage. I had to go there. I had to walk the line. I had to see the bottleneck with my own eyes. I had to talk to the engineers and technicians who were actually doing the work. And when I got there, I saw the problem. The problem was in 2 of the 4 zones of the module assembly process where the cells are packaged. And the cause of the problem, that was the worst part. The supplier failure and the software war, this is the craziest part. The complex automated manufacturing systems for that battery module line, we didn't design them. They were done by manufacturing system suppliers. We had essentially outsourced the automation of our most critical core bottleneck, a stupid mistake, one we will never make again. We had trusted the fate of the company to a third party that did not have our same level of urgency, that did not have our engineering philosophy. And the supplier dropped the ball. Their system didn't work. It was overcomplex, badly engineered, unreliable. It was constantly failing. We had no choice. In the middle of the crisis, with the financial doomsday clock ticking, we had to take over. We kicked the supplier out. We had to significantly redesign the whole thing. In the middle of the battle, this meant our team had to rip out the supplier's automation and build it themselves, while simultaneously hand-building modules just to keep Fremont alive. The worst part was the software, the programs that run the robots. They were a mess. Our team had to rewrite all of the software from scratch. I described this in a press call. I said our team had accomplished a workload equivalent to 20 to 30 man-years of software in 4 weeks. That is not an exaggeration. That was the level of superhuman effort required. Our engineers were sleeping under their desks, drinking Red Bull, coding nonstop for weeks. This was an incredibly painful lesson in vertical integration. Never, ever outsource a core process. Never trust your critical path to someone who does not share your mission. But there was a silver lining. That supplier failure was a blessing in disguise. It forced us to become great at this ourselves. That 30 man-years in 4 weeks effort forged our automation engineering team into the best in the world. We developed an in-house competency for complex manufacturing automation that no other car company on the planet has. We paid for our education. We paid in blood, sweat, and lack of sleep on a factory floor. But we learned, and that is what created the 10-year lead Sandy Munro talked about. The financial doomsday clock. Now put all this back in the financial context. Remember those numbers. $710M loss in Q1, $7,430 a minute in cash burn, about a month from bankruptcy. So when I say I was fighting on the battery module line, understand the context. It was a fight to the death. Every module we had to hand build while the automated line was down was a financial catastrophe. Every hour the line was stopped was hundreds of thousands of dollars gone. It got so bad that my CFO, Deepak Ahuja, and I had to institute an extreme financial control. We announced that he and I would have to authorize every transaction in the company. Every single expenditure, no matter how small, had to go through us. That was the level of granular control we needed to survive. Personal responsibility in this context was a literal race. It was a race between our speed of engineering innovation and our rate of cash burn. We had to accelerate our rate of learning faster than our bank account was draining. Sleeping on the floor wasn't a stunt. It was my tool for accelerating the rate of learning. By reducing information latency to 0, I was doing everything physically possible to make sure our learning rate won the race. Rewriting the factory OS, pain is a great teacher, and production hell was a brutal one. What we learned from that fire was not just how to build the Model 3. We learned a new way to think about manufacturing entirely. We rewrote the factory's operating system. First principles thinking for manufacturing. I always talk about first principles thinking. It's how I approach everything, from rockets to cars. First principles thinking means you break a problem down to its most fundamental truths, the things you are sure are true, and then you reason up from there. It is the opposite of reasoning by analogy. Reasoning by analogy is when you do something because that's how it's always been done. The auto industry had been operating on analogy for 100 years. They copy each other, making small incremental improvements. Production hell happened because my initial attempt at first principles was flawed. My premise was wrong. I was too focused on automation as the end goal. So on the floor, I had to redo it. I had to reapply first principles. I had to break the manufacturing process down to its fundamentals. What is the fundamental question? What are we trying to do here? We are trying to transform raw materials into a working car. Next question, what are the fundamental requirements to do that? Answer, you need parts, you need a process to assemble them, and you need a system to move them out of the ashes of the flufferbot. And the conveyor belt mess, we developed a new process. A mental operating system for solving manufacturing problems. We call it the algorithm, the 5-step process. Here's the 5-step process. It was born in hell. And I now apply it to everything: car design, rocket building at SpaceX, even organizational structure. And the most important thing is the order. The order is everything. Step 1, question the requirements. This is the most important step. Question every requirement. Every part, every process, every spec, be radically skeptical. And, as I said, attach a name to it. Never accept a requirement from a department. The safety department says, we need this. No. Who? What person's name? Let me talk to them. Most requirements are garbage. They were put in place by smart people, but perhaps in a different context. And then they live on forever. Step 2, delete the part or process. This is my favorite step. If you cannot justify a requirement, delete it. Just get rid of it. Don't try to redesign it. Don't try to improve it. Delete it. You may have to add it back later. That's fine. My rule is if you do not end up adding back at least 10% of what you deleted, then you didn't delete enough. Most engineers are trained to optimize. They are not trained to delete. Deletion is a superpower. We deleted the fluffer bot. Step 3, simplify and optimize. Only do this after you have questioned and deleted. A common mistake, as I've said, is to simplify and optimize a part or a process that should not exist. This is exactly what we did with Flufferbot. We spent thousands of engineering hours trying to optimize a process that should have been deleted because it was based on a false requirement. Only after you have deleted everything you possibly can, you take what's left and you simplify it. Step 4, accelerate cycle time. Now, and only now, do you try to make it go fast. My mistake in the Tesla factory, I mistakenly spent a lot of time accelerating processes that I later realized should have been deleted. I was trying to make the crazy conveyor network run faster. I was trying to make the Flufferbot pick up fluff faster. I was doing step 4 before steps 1, 2, and 3. It was idiotic. Step 5, automate. This comes last, dead last. The big mistake was that I began by trying to automate every step. I started with step 5. You only automate a process after you have questioned its requirements, deleted the unnecessary parts, simplified what's left, and accelerated it. If you automate before that, you are just automating a mess. Automating a garbage process gives you an automated but faster garbage process. The entire production hell can be summarized as, I did the algorithm in reverse order. Sleeping on the floor was the painful, brutal process of learning to flip it right side up and start at step 1. The proof, the tent. You want proof this algorithm works? Look at General Assembly Line 4, GA4. We were desperate. We had to hit our goal of 5,000 cars a week. It was the target we promised Wall Street. We were missing it badly. We were out of space in the factory. We were out of time. So we did something insane. We built an entirely new assembly line, a third line in a giant circus tent in the parking lot outside the Fremont factory. Everyone thought we were crazy. The press laughed at us, and they had a point. It was a temporary structure, open at the ends. It didn't have the proper humidity and temperature controls that traditional automakers will tell you are absolutely essential. But we didn't have time. And here's the amazing thing. We built that entire general assembly line in 3 weeks. 3 weeks. A car assembly line normally costs billions of dollars, and 2 years to build. We did it in 3 weeks for a tiny fraction of the cost. The tent was the perfect physical application of the 5-step algorithm 1. Question requirements. Who says an assembly line needs a permanent billion-dollar concrete building? What is the fundamental requirement? You need a roof to keep the rain off and a flat floor to put the equipment on. 2, delete the concrete building. Delete the 2 years of construction time. Delete the permitting bureaucracy. 3, simplify. Use a tent, a semi-permanent structure. 4, build it in 3 weeks instead of 2 years. 5, this is the most important part. The line in the tent GA4 was significantly less automated than the lines inside. We had learned our lesson from the Flufferbot. GA4 used more humans for the tasks that required flexibility and adaptation. It was the physical embodiment of the humans are underrated confession, and it worked. That tent, GA4, is what got us over the 5,000 car per week line. That tent saved the company. It was born of desperation, built on first principles. And it was the proof that the 5-step algorithm was the way, this is the way. In the end, why does this matter? Why go through all this pain? Why bet the company? Why sleep on the floor? Because it's not just about building cars. It was never just about cars. This philosophy of absolute personal responsibility, of obsession with first principles, of a willingness to eat glass, was forged over years of failure. And it is the only prerequisite for the missions we are trying to accomplish. Lessons from Falcon 1, trial by fire. This was not my first time looking into the abyss. Model 3 production hell wasn't even the first time both my companies faced death at the same time. The first time was in 2008. At SpaceX, we were trying to build the Falcon 1, the first privately funded rocket to reach orbit. Our first 3 launches in 2006, 2007, and early 2008 all failed. 3 straight times, failure, failure, failure. At the exact same time, in 2008, Tesla was running out of money in the global financial crisis. We were trying to ramp production of the Roadster. I was out of money from PayPal. I had to make a choice. I could split what little I had left between both companies, and both would die, or I could pick one. I couldn't do it. I put everything into both. We had just enough parts and just enough money at SpaceX for one last launch of the Falcon 1. It was September 2008. If that 4th launch failed, SpaceX was dead, period. Tesla was also on the brink of bankruptcy. I've said before, I was borrowing money for rent. The pressure was unimaginable. That was staring into the abyss and eating glass at its most elemental. I was there on Kwajalein Atoll, living in a shipping container, trying to debug a rocket. I've said, failure is an option here. If things are not failing, you're not innovating enough. This is true. But there is a limit. You cannot fail forever. The leadership philosophy forged on Falcon 1 was the same. You must confront failure. You must diagnose it immediately. After the 3rd failure, the team found the cause a collision between the 1st and 2nd stage and fixed it in weeks. And you must work with an insane intensity, with an absolute faith that you will eventually succeed, even in the face of brutal facts. When that 4th launch of the Falcon 1 succeeded and reached orbit, it saved the company. A few months later, on Christmas Eve 2008, we closed the financing round for Tesla, saving it from bankruptcy just days before it would have run out of money. Staring into the abyss with the Model 3 inches 2018, it was still terrible, but it was a little easier because I had been there before. I already knew what waking up screaming in pain felt like. Personal responsibility means you don't quit on failure 1, 2, or 3. You keep going. The parallel Raptor engines and the future of this pattern repeats. It has to. A few years later, when we were in a production crisis for the Raptor engines for Starship, the engine that will take us to Mars, what was the problem? Manufacturing. I sent an email to the entire SpaceX company. I said we were facing a real risk of bankruptcy if we couldn't get the Starship flight rate up. And what did I say in that email? I said I would be personally on the Raptor production line over the weekend and for the following week. People were, again, surprised. They shouldn't have been. This is the pattern. When the critical path of the mission making life multiplanetary is threatened by a manufacturing bottleneck, the CEO must be on the line. Whether it's software, cars, or rockets, the philosophy is the same. The physics of manufacturing and the physics of engineering demand fast feedback loops. By being there, I am acting as an accelerator for that loop. My responsibility is to apply force to the point of greatest friction. Conclusion, the burden of the mission. This brings us back to the original question. Why? Why do any of this? Why care this much? Why sleep on the floor? It's not to flex. It's not for money. I don't care about money. It's because the things we are doing have a purpose. The Model 3 was not just a car. It was step 2. And 3 inches, our secret master plan that I wrote back in 2006. Step 1, build an expensive low-volume sports car. Step 2, use that money to build a more affordable medium-volume car. Step 3, use that money to build an affordable mass-market car. All of it was to help expedite the move towards a solar electric economy. The Model 3 had to succeed. It was not an option. The company's survival and the progress of the mission depended on it. This is a mission-driven company. When you work on a mission like that, whether it's accelerating sustainable energy or making life multiplanetary. You don't work just for a paycheck. You choose to work hard. You choose to go above and beyond. So when people ask me about sleeping on the floor, they are asking the wrong question. The question isn't, why would you sleep on the floor? The question should be, how could you not be there? If the mission is failing, if the company that thousands of people have poured their sweat and tears into is dying, where else would you be? You can't be anywhere else. It's not a choice. It's a necessity. It's physics. If the mission is failing and you are the leader, you go to the front line. You apply your own force to the biggest point of friction. You diagnose the problem from first principles. You question the requirements. You delete the stupid stuff, like the Fluffabot. You admit your mistakes publicly and say humans are underrated. You build a tent in the parking lot. You eat the glass, and you don't leave. You don't go home. You sleep on the floor. You stay until the job is done. That is personal responsibility. Thank you.